We're about to work a couple of examples from the chapter review in Cambridge, and we're going to use Financial Solver to do it. Remember, what we're going to do is we're going to use this rule that we'll just make sure we keep consistent. And that is when the bank gives us money, or when we borrow something, we consider that a positive amount. So let's write bank gives. We consider that a positive amount. When we give the bank some money, that is, like we invest it, that we're going to write that as a negative amount. So give bank. Okay, so it's important to use that convention for reasons that you'll see that are really clear. So we're going to go to Calc 1 and we're going to use compound interest. Okay, so yeah, Financial Solver, it's really good. It's really powerful, but it ultimately wasn't designed for a Year 12 further mathematics course, and more designed for accountants and financial planners and things like that. So the interface is really intuitive for them, not as intuitive for us. So we're just going to have to sort of really accept that it's going to take a bit of trial and error to work out exactly how to use it. Okay, so let's do this question here. Helene has won $750,000 in a lottery. She decides to place the money in an investment account. So because she's placing the money in an investment account, she's giving that money to the banks. So we're going to list that as negative. Okay, and that's the present value. So at the moment she's got $750,000. It pays 4.5% interest, so let's put that in, because if you want to find out how it works, go to help, and that the interest is the annual interest rate, so you must put it in as an annual interest rate. Compounding monthly. Okay, so what we do here is now we put down 12 and 12. Now I'll explain why generally speaking it's the same number, but certainly number of times interest is compounded per year is 12, and usually that's the number of payment installations. So generally we keep that consistent with the number of compounding periods. Okay, how much will Helene have in the investment account after 10 years? Okay, so she isn't making any sort of contributions to the payment. So where it says payment, PMT, we put down 0. Now, it's after 10 years. So if she's doing 12 payments or 12 compounds a year, then we need to do this or multiply it by 10, because she's doing 10 lots of these 12 compounds a year. Now you'll note that what Financial Solver does is it'll rewrite this as 120. It'll execute the multiplication when I click on another part. So have a look at what happens later on. What we want is the future value. So we want to find out what this $750,000 does if it's invested at 4.5% interest compounding monthly. So we go to future value. That is, what will it be worth in 10 years' time? And there it is. So what it does, and you note that the number of compounding periods is 120 now, 10 lots of 12 compounding periods per year. Okay, so that's the answer to the first one. How much will Helene have in the investment account after 10 years? Okay, and that's kind of because, and it's positive, because we can kind of say that that's what the bank gives us. If I, in 10 years, want to take all the money out, I'll have $1,175,000. Okay, so that's our answer to question 1 there. Let's write that in. It's 1,175,244.58. Alright, after the 10 years are up, Helene decides to use her money to invest in an annuity, which pays 3.5% per annum, compounding monthly. And what she's doing is she's going to take $6,000 per month for her living expenses. We want to know how long this annuity will last. Okay, so let's modify this, 3.5. The number, that's what we don't know. That's what we're trying to find out. Okay. Now, what she's doing is she's investing this $1 million in the annuity. So we're going to actually go edit and copy and paste that into the present value, because that's what it is. I know that that was the value that we used after 10 years, but now we're going to say that that is our present value. Now let's put a negative sign out the front of that, because that's saying I'm going to slap this into the bank. So I need to make that negative because I'm actually, is that positive or negative? No, I'm giving the bank that money, so it's negative. That's right. Okay, now we need to put something down as a payment, okay, because she is taking out $6,000 per month for living expenses. So we're going to write this as 6,000. Okay, now what is clear from this question is that the 6,000 a month she's taking out for living expenses will deplete this $1 million, okay, and so what we want to do is find out how long it will last for, basically, how long until the future value of this $1 million is $0. Okay, now we're just checking that we're still on a month split on the interest, which we are. So now we can go straight to n the number of compounding periods. Alright, so it says 290.82, and what we're going to do is write the answer to this as 291. It's 291 because basically we can get the 290th. We can take 600 out on the 290th payment, and we'll try to take something out on the 291st payment. It won't be $6,000, but it will be something. Okay. Helene's accountant suggests that rather than purchase an annuity, she places the money in a perpetuity so that she will be able to leave some money to her grandchildren. If the perpetuity pays 3.5% per annum compounding monthly, how much is the monthly payment that Helene will receive? Okay, so let's change a few things around here. So we're still investing the same amount, the $1 million, but now what we want, a perpetuity means that our amount stays exactly the same. So what we're going to do is copy, edit, copy, and stick that into the future value. Paste. Alright, so basically what we're saying is we're going to keep taking money out or making payments, and the payments we want to take out are monthly payments. So we're going to switch the number of periods or installments to 12. Alright, and now when I click on PMT or payment, that'll basically tell us what, or the amount I can take out per month to keep the amount in my bank account at 1,175,000 blah blah blah. So let's see. And so basically this is saying that the bank will give us, or we can take out $3,427.79 or 80 cents, which is pretty good, because that basically, I mean, that's $3,500 a month, and I've still got $1.1 million or $1.18 million in the bank. So let's write that up. That is my payment. Oops, get rid of that. My monthly repayment is $3,427.80. So again, you can see that using Financial Solver, it is a little bit tricky and confusing, but yeah, look, it just takes thinking about things a little bit differently, and that's the hard thing about it. So anyway, there's one example of when we're actually giving the bank money. What we'll look at next is one example where we are borrowing money, or the bank is giving us some money.